I write a compiler for an imperative programming language with an Oberon-like syntax. The compiler is self-hosted and written in itself, but not finished yet. For the current stage of the compiler, the stage 21, can only use the features that are already implemented. And still a lot of stuff is missing, so the language that I use to implement the compiler is not finished and missing a lot of features. And recently I implemented 1 byte types, characters and booleans. They were supported before, but they were not handled as 1 byte types, but as words. So the target of the compiler is RISC-V 32, so a hardware word is 4 bytes, and booleans and characters were handled as 4 byte types, and now they are handled as 1 byte types. And now I'm going to modify this stage so that it uses now booleans and characters, and see whether we have any problems and something should be fixed. Probably there will be problems or something that I missed, so it's very possible. Now I have here this comment. So current byte is compared with an ASCII code, and we want basically to replace this these ASCII codes with characters. So we can just remove this thing and replace it with the actual character, and here the same. And now we can try to compile it. I use Ninja for building the compiler. So the compiler is built with the previous stage, and after that it compiles itself. So the stage 21 compiles itself. I also use Rake as a help tool for implementing some tasks, and the default task is an additional test that just compares the output of the previous stage of the compiler with the current stage, and it was actually very good metric to validate that the compiler still works, and I could catch a lot of errors this way. I wonder whether it can be not. Probably it won't work, so I have this not operand, but it generates currently an invalid instruction. We should look later into it. So here we have true. The compiler does very limited error checking, so it almost does not any error checking. So I actually should do the compilation step pretty often just to validate that the compiler still works, because it can be something difficult to find the errors after changing a lot of code. I want to implement the most important features first, so the core language, and after that do work on the error checking. So this is done. So that's it for characters that I can find. The one problem that I definitely have is that quality doesn't produce a Boolean operation currently. But it seems to work this way. And probably I shouldn't change result to Boolean yet. Seems actually to work. What will happen if I replace equal with not equal? Then the compiler crashes as expected. Okay. Now I have a few special functions, load byte and store byte. These functions just write, they are automatically provided by the compiler, and they basically load byte or store byte at some address, because as I said, compilers supported only 4-byte operations. And we actually want to replace these two functions in the next stage with native language features. For that, I want to generate a new stage, so we actually want to save the current progress. I already have a stage, that 22, that I used for testing. I copy it into the boot, and in this stage I do rake convert. Just copy stage 21 into 22, overriding the current 22 stage. So the stage 22 is basically the copy of the stage 21. Now we want to update the rake files. I think Ninja build, and now if I call Ninja again, then it compiles the new stage and the tests pass. So now we can open the stage 22 and see whether we can replace. The one thing that actually can be probably modified, or this is already the case, so allocated is a Boolean here. It wasn't the case in the stage 21. So here allocated is a word, and here it is a boolean. Yeah, load byte and store byte. So current byte should be probably be a character, and contents is a character pointer, and load byte can be replaced with the dereferencing. So here we still have checks for single characters. So next character is a character. I open another window and do compilation here, so that we can do something in parallel. And actually we check here the escaping, and first I check if this is an escape character. So 92 is probably a backslash. And this thing already fails. Okay, let us actually replace first these ASCII codes with actual characters. I should probably remove support for some escape characters. I just taken them from C, but I think that most of them aren't usually very often anyway. So we can just keep backslash, new lines, carriage return and null character, quotes, and the other stuff can be probably removed. So here we save the actual character. I even can replace this with characters, because the previous stage should be able to compile them. But first we do this thing here. So form feed, return carriage, vertical tab. This is the double quad, and this one is a single quad. Let us see whether we can compile it. I think we should be able to. And now we have the null character. null character is basically a 0. And now we can replace these ones. So here we have next character. Here we would have a new line, a bell, backspace, tab, form feed, and the 0 character. Now let us try it again. So a next character should be a character, character literal node. What is it? Literally character literal. It has the value, and this value is a word. Later I want to have type extensions so that literals extend a type that has this value field. Actually, no, it is not needed. I can just change the value here to a character pointer. So we revert it. Then I change this to character pointer, and I do the same in the previous stage because it should work. There as well. So we can just write a character pointer here. The compilation will take a bit more time because it compiles now the 21st stage and the 22nd that I'm working on currently. Looks fine. Now I can change this one to character, and I can say and I copy this next character to the brand value. So this one should work should work later, so theoretically, but it won't work yet. We probably should add an additional variable with the proper type. Let us call it current position. It will be a character pointer, and we assign this thing to it, and we will say that current position is a literal value plus 1, and then we can dereference this pointer. And the final test produces some output. meaning that something is wrong. So here we can add ones to the current position once again. So we can say that current position is current position plus 1, and then we can dereference it here. I wonder whether it would work if I change this one to a word. Yes. The problem can be that the operand value is a word, and probably the assignment between different types doesn't work properly. So we probably should implement a proper casts so that that we can extend a 1 byte value to a 4-byte word. But for now, I would say that I just leave it as is, and let us look for other load byte usages. And here we have now another write C example that we can replace. 34 is a quad. And 10 is probably a new line. So add byte. Here we have this compiler strings copy. Oh, it's even a local variable. That means that I can locally change the type of this variable, so both of them are basically character pointers. And current byte is a character, and then we can dereference it at 1 and write this stuff, and I already changed the type from word to the character. So there are still quite a few usages. So cursor finish. This is this one. Both are actually character pointers. 10 is what? A new line, I think. Interesting why the comparison with a character doesn't work, but only with a number. I just had a comment here, so I can look at the generated code later and see what actually happens. But we do not need this character variable anymore because we can just compare directly. So and now to the next load byte, and load byte isn't used anymore. Let us look for the start byte instruction, and then we can remove these built-in functions probably. So start byte, exactly with this one is also an ASCII code that should be a character. So label with dot is a word. It is not a word, it should be a character pointer, and we assign it a value here, and then we can dereference it and assign a dot to it. So here we assign a value to the current byte. No, we assign a value from the current byte. So what is actually this compiler strings position? It is a global variable. I haven't tested this feature with global variables, I think. So it will be interesting. We replace the word type with a character pointer type, and that should mean that we can reference it and assign the current byte to it. And this is actually the only place where store byte is used. So store byte stores A0 in the value pointed by A1. So the code is actually correct. Now we should get rid of this store byte. What is different? So we save current byte in compile strings position. And then we add it and continue. Okay, the string generated here is garbage. Actually, there is a way to fix this problem temporarily hack, because it is the last usage of this store byte function. We can probably just call memcpy and copy one single byte so that we can remove the functions, these built-in functions that we do not need anymore. So compile string positions and we copy, we give the pointer to this, no, just the variable, I think. So we give the compile strings positions to it since it is a pointer, and we copy the current byte into it, and a single byte basically. It is probably a character, no, it is not character parsing. I should probably just find how many symbols. Oh, I cannot, because I check for the escape sequences here. Okay. But this one could probably at least work. Yeah, it does, and now we can remove this stop byte call, and here we can add a to do, so we can look into that problem. Result is actually the previous string. So at the end we can call memcpi. Contents is adjusted here, but contents is basically string plus 1. This is the source. The string, we do not modify the string variable itself, I hope. The length is length to copy, and the target is compiler strings position, and we just modify it here. But we can keep it as is. And just add the amount of bytes copied at the end. So just with a single addition, and here we just go through the contents, check for double slash, and wait until we encounter double quote. Yeah, that looks fine. Now we can remove this comment. So instead of copying a single byte, we just count how many characters do we need to copy, and copy them at once at the end after the loop. So I need to advance content because it is what we actually check, and this one because not all are counted. Length to copy, and we need to add one here. We actually can get the length if we subtract string from the contents, but whatever, that can just remain as it is. Then we have result contents. That's fine, I think. So we can remove this, and now we can remove the the built-ins itself. So we generate the text section here and just write two functions, but otherwise I do not do anything here. I also do not generate TIC or something like this for these functions, so we can just remove these two lines. Okay. And here I still have one to do. This function is actually pretty long. So here we load 10 into T0. So this is the new line. Here we compare stage 22 validation stage with its own output, and we get different values here. Oh, this is the boot stage and not the validation stage. So I need the validation stage of stage 22. And we need the line 32,000. Exactly here. And the value that it loads is some garbage. If we compare it with the output of the boot stage, so this is the same place, and basically here we load 10, so the new line, but in the other case it just generates some garbage. I think that I probably how do we handle the escaping once again? Yeah, escaping is the problem. So here the problem is probably is that if I assign a character, I assign it to this value field, but this value field is not 1 byte field, but a 4 byte field. And since I do not do proper casts and extension of the register value, it assigns garbage to it. So for now we need to revert this change and assign numbers here. What function is it? Is it TIC character literal? So new line is 10, backslash is 90, 92. Oh, because it is stage, I can copy the values from the previous stage instead of the div. So we can open stage 21 and go to this function, and here we have the values. So 92, new line is 10, bell is 7, backspace is 8, tab is 9, form feed is 12, carriage return 13, vertical tab 11, double quote is next character, and single quote is next character as well. One problem is that we still assign this next character otherwise, so if it is not an escape sequence, we just assign this character. Quote is, double quote is 34. Double quote is 34, and single quote $39. And this is 0. Next character is not a character but a word. Okay, and here I tried to assign an end character, but here I assign a next character, which is a word. That should be fine. So now it compiles. We did some work. I think that I do not have to-dos anymore, so this to-do is done. This is fixed. We can write stage 22 here. We can remove the comments because this stage haven't implemented anything yet, and we can remove this test function that I used previously to test these new features. And now we will continue to work on the stage 22 instead of stage 21. And so actually we haven't implemented anything new, but but we used a new feature that was implemented in the stage 21, and we tested this feature in the compiler itself by using it in the code. And I think that I will finish here for today and continue to work on the compiler next time.